Welcome. PVG Menon is among the best known names in the semiconductor industry in India. From economics to IT was quite a leap. When PVG worked first with CMC Limited and the European MNC Siemens. When he joined Analog Devices in the mid 90s, he was introduced to the concept of technology platforms, which has become very common in usage today. And he learned the ropes in running a global product line with teams distributed across the world. We will speak of how he led the India Semiconductor Association and the complexities of growing the industry in India. This is episode 90 of My First Job, the podcast that covers engaging career journeys. And every single one is full of twists, turns, and insights. I'm Venu Gopal Nair, the host of the podcast and CEO of Ideascape Communications, an advertising agency into branding, creative, and design. So settle in, sit back, and enjoy the conversation. PVG, welcome to the show.
Hey Venu, thank you. Good to be here and looking forward.
Wonderful. You said you grew up across several cities in India. So, which were the cities that were the early part of your, in schooling and college? And,
Um, I think Delhi, I was born in Delhi. I've kept circling back to Delhi multiple times. My father was in the Air Force, so I've lived in Shillong, Coimbatore, Chennai, um,
okay,
a brief stint in Calicut, and then professionally, Bombay. It was still called Bombay in my first stint, Mumbai in the second.
okay,
Bangalore, Bengaluru now. A brief time when it was Madras, not yet become Chennai.
okay,
And yeah, I guess as they say, a
okay.
rolling stone.
Yeah, but what has your experience been? Have you made more friends or learned to make friends easier because you constantly shifted? Because that's another thing. Some people think that living in one place tends to grow deeper friendships, whereas there are people who say that no, it gives me the opportunity to make new friends in new places. So, what has your experience been?
That's a difficult one, Vino. I guess, like a lot of people, I have a lot of acquaintances. The one
Okay,
advantage of shifting to multiple cities is that you can
okay,
strike conversations very easily.
right,
There's something, whether it's food, whether it's places, whether it's whatever, you can strike conversations. But if you ask me, really deep friendships, I have friendships going back not so much to school days, but to college days, and then
right.
early part of my working life, paying guest accommodation in Bombay when you live three
Great
people
place
in
to
a
be.
room. So I'm very privileged to have a few very, very good friends. And I wrote a post on this some time back. We had a reunion, maybe some of us were meeting after 15 years. And
Okay,
as that song goes, those were the days, my friend, we thought they'd never end. So the conversation just picked up again.
wonderful. So, in your mind, what were the things that because I found that from economics to IT. So obviously, there's a lot that happened in between in terms of how, in your mind, how did this whole process happen?
You're taking me back down memory lane. So, look, when I studied economics, I was at that time two things as a college student. You read Ayn Rand and Atlas Shrugged, and you're hell bent on you have a view of the world, and then you
Right.
study economics. And at that point, I thought I'll go join the Reserve Bank and eventually get into macroeconomics. Fascinated me, and so on and so forth. Um, and then one fine day, I see a ad to sell computers. Remember, these were
Okay.
the days when personal computers had two floppy drives, and you had the PC, the PC XT, and the PC 80. Our generation will remember.
Absolutely.
And they said, why don't so I went and got selected, sold a PC. I had no clue what it was, but we would go around with the magic words, we're selling an IBM PC compatible.
Okay.
um, and then one fine day see an ad for a technical writer, and all they said is you should have English literature graduates with good communication skills.
Okay.
So something in my mind said I can write and speak better English than some of the English literature graduates I know. So this was
Yeah.
in Madras. I go to
Okay.
the interview, and there was this lady from the US who was interviewing, and she asked me, "You're selling computers. Why do you want to come and be a technical writer?" I
Okay.
was, I think, all of 22 years old. So you say
Right.
stupid things when you're 22. And I told her, I think, madam, life behind the keyboard is better than life selling it. And I think that line got me hired.
Uh,
So yeah, that was a wild ride. I did a lot of different things. Did computer graphics, did technical documentation, worked on large projects. Uh, yeah, that was how economics to IT happened.
so you got a sense of what the industry was about, even though you didn't come from an engineering background, you got soaked into the IT world of the time.
I did, and the one, if I can say, if I look back and say, a one defining feature of uh, my professional career has been that I've been an absolute um, voracious consumer of information. So in those
Okay.
days, I used to live in Bombay, and those of those of us who've been to Bombay or live in Bombay know that there's a stretch between VT railway station. You come down towards Fort and walk towards Churchgate, and there are all these guys who sell second-hand books.
Yes.
And I used to go and pick up all you could get those US magazines which are about 6 months old, Computer World, PC
Right.
Magazine, Byte, and I would buy all of those and I would voraciously read them. And I think
Okay.
self-taught, plus the advantage of working in a large project organization like CMC in those days, it was a public sector, was that you had the privilege of working with absolutely fantastic set of people, and I would go
Right.
badger them with questions, and I think they would teach me stuff so that they could just get rid of me. So I would stop asking them questions. And
That's another lesson. Be a pest if you want to learn.
absolutely.
Yeah.
And yeah, so looking back, people say, "Oh, you burned the midnight oil," but honestly, it didn't feel like it. I was having so much fun learning new stuff
Right.
that,
Right.
yeah.
So, what is the difference? I find this quite unique. The number of people who are curious and who just soak up the information versus people who plateau early on. In the sense, I learn something and then I'm comfortable not going deeper into something. Do you think it's part of that person's nature, or is it? Do you think it's a trait?
Tough one to answer. I don't know. I'm innately curious. I mean, I'd love to talk to you about advertising. I wish I knew more about how you influence people, to go and buy soap X or soap Y or whatever. Uh,
Right.
Technology fascinates me. And more and more, I guess, because of the time I've spent in engineering related areas, I'd like to figure out how things work rather than and what is the effect of what they do rather than just use something. So yeah, curiosity
Okay.
has been something which has kept me going. I mean, you give me something nice to eat, I'll probably ask you how you make it. Don't ask me to repeat it. It's information filed away. The best I can do
Okay.
in cooking is make Maggie noodles.
Great. So, how did analog devices happen?
Oh, that was interesting. I was working for a company, and we had done the first multimedia project. Um, we were using a technology called digital video interactive, very old. I don't think it is around today. And somebody got into a conversation with me, one of the headhunters, and he said, "Hey, there's this company called Analog Devices." And remember, I knew the software part of things. I knew how to do projects. Um, those days, the hardware industry was considered a bit of a step down, and
Okay.
semiconductors. I think I first asked him, "How do you spell it?" And I asked him, why is it a semiconductor and why not a full conductor? So he said, "Hey, listen, why don't you go speak to the country manager of this company?"
Okay.
Coincidentally, analog devices was looking for people who could sell, who had experience in doing projects and could do solutioneering, as they called it. Because in the 90s, computer chips were sold with a data sheet. You had this
Okay.
300, 400 page technical document which talked about voltages, which wire would do what, etc., etc. So I had this conversation. I had multiple conversations with Analog, and they talked about things like technology platforms, and that intrigued me because in those days, remember, this is what, 94, 95. Platforms, as I knew it, existed in railway stations. So I said, what is a technology platform? And got sufficiently intrigued to join. Um, and that was the first time I had, got involved in doing something which was global, managing distributed teams, dealing with global customers, all of that. So it was a fun ride. And I ended up taking over and establishing what is called the professional consumer or prosumer audio business for them. And in a space about 5.5 years, we had managed to sign on every brand name. Surround sound was just starting off, so Dolby AC3, DTS, all of that. So one had to learn about, um, obviously, audio technology, what is sound all about. One had to learn about digital signal processing. One had to learn about how um, design sockets were won in electronic products. And again, I would read, I would attend every trade show, walk around, and now I vividly remember what someone said. Um, when you're a product line manager for a large global corporation, there are three ways you look at things. One is obviously you look at your competition and what they're doing. You look at what your customers are doing, but you also look at what your customer's customer is doing.
Okay.
Because as a semiconductor company, remember that my design cycle to get a new chip out is a minimum of 2 years, and then it takes the customer another 18 to 24 months to get that chip into production. So you need to be a combination of a good technologist, a good marketeer, and a little bit of an astrologer, because you
That's
will have to
that's
make
it's an
no.
amazing combination of things because, like you said, the prediction is 4 years hence. So there is a bit of astrology involved, even though you can get the other parts of it right.
Yeah, I mean, and let me say we've gone spectacularly wrong as well, and a lot of time, 25 years have passed. So many years ago, when MP3 was happening, you may remember it came with what was that company which used to rip music off
Napster,
CDs, Napster.
yeah,
And every single day you would wake up and hear somebody else has filed a case against Napster.
right.
And I remember at one of the trade shows, somebody came up to me and said, "Hey, there is this program called MP3. Would you do it for us on your chip?" And we went back,
Okay.
looked at it, and we said, "Okay, college students ripping tracks of CDs and getting sued. No, we don't want to do anything with it." 1 year later, we were scrambling to get MP3. So sometimes you go spectacularly wrong.
Yeah. And I think torrents and Napster were among the defining technologies of how information and the network actually spread. Now, in retrospect, we can look at them as threat to established businesses. But I think back in the day, they really, even today, when I look at torrents, I wonder how this guy managed to do it, because it's like managing a crowded road and then saying, okay, I will literally figure out which piece in this broken file goes somewhere and how will it be
Yeah.
downloaded. When you look at the complexity of how that is managed and how practically every technology today rides on something which had to do with streaming or broadcasting or whatever, how did that initial foundation was that, which is amazing. But the hardware industry, you were among the people in India who was there in its infancy, because analog devices. So, how did things progress at the end of 5 years? What changed?
So at the end of 5 years, what had happened was I had hit a certain plateau. The product line was very successful. The next step meant moving to the US. And call me
Okay,
crazy, but um, that didn't excite me so much. Um,
okay,
to quote Carl Sagan from A Pale Blue Dot, visit, yes, settle, not yet. So, and then Philips came along, and Philips was an interesting opportunity because Philips was setting up a reuse technology group with silicon IP being reused. And 5.5, 6 years into selling standard products with software that could be downloaded onto a programmable signal processor, doing ASICs out of it. One sort of knew that business. Silicon IP intrigued me because you were doing a custom chip for every customer that came along, or within a customer, every application. Second, the whole concept of a repository of that under a central technology office, and essentially spinning variations of your intellectual property, silicon IP, um, and doing a new chip. You could have 50 new chips out of one silicon IP, depending on how you built it around. So that sort of intrigued me, and I went from managing a family of two DSP families with variations, of course, to 11 processor families, I think 13 or 14 connectivity options. And
okay.
it was like going from, I don't know, one of these, as we would call it, tattagades who will give you idli and dosa and that's it, to
To
one of those restaurants which have 25 items on the
lavish
menu.
menus. Great
And
analogy.
and then you got into this whole complexity of the CPU would work with a certain bus. We supported three or four of those main architectures. So then you sort of start to drill down and say, this is my processor, this goes with this bus. If I have this combination, this is what works. And that was fascinating. And yeah, and then
That's what kept
the chance to
the.
fabricate it either in our own foundry in France or in TSMC.
So, let me ask you a very basic kind of question. What were these functions earlier performed by? How did semiconductors or semiconductors make a difference?
Um, you How long do you want me to speak on this thing? I
Yeah,
I
you
also
can
have.
speak for as long. I just want the audience to understand this, because they need to know that there was a shift. They don't understand the shift because in software you can figure out, okay, to some extent. Recently, I was telling people, until 2001 and the iPod came out, the device and the substrate on which you played the song were different. It's only when it
You had
converged that the whole thing changed.
you remember the Walkman with all those cassettes, and we
Yes,
would have those cassettes.
yes,
We would all carry
buttons.
a pencil so that we could spool the cassette.
Yeah, yeah.
Yeah.
So, if you can tell me, explain to students from college as to what was that change about
So
the
we started with
semiconductors.
transistors, so we started with transistors and then made way to microprocessors. Microprocessors became more and more complex, but there was a single central processing unit, so that had an arithmetic logic unit, it had memory, it had all of that. At some point in the um, early in the late 90s, early 2000s, the semiconductor industry figured out that you could put more than one CPU onto a single die, and the concept of multi-core came in. So in the 80s, there were, or even in the 90s, there were these supercomputers which had different, parallel processing. You would have multiple computers, and then you would figure out how to do this. Now you are shrinking everything into a single chip or into a single die. And I remember reading an IEEE article from, I think, sometime in 2010, 11, where a professor from Stanford wrote that the hardware industry has long ago figured out what to do, how to put multiple cores on a single die. The software industry still doesn't know what to do with more than one processor, right?
Okay. Okay.
This was the mid 2000s, and then of course software evolved. And today, if you look at the most ubiquitous computing device, which is a smartphone, you will be unlikely to find a smartphone which doesn't have at least four cores on it. And the software
Wow.
industry has figured out. So one of the cores is running the GSM stack, one is running something else. Your radios are being controlled. You've got multiple radios on it. You've got your Wi-Fi, you've got your GPS, you've got near field communications for payment options, contactless payments. And that is sort of how this whole thing evolved. And right now, Venu, we are in the midst of another transition. um, this is what I call the disaggregation of the semiconductor value chain. And
Okay.
till about 5 years ago, if you were a product company, if you were an Apple, a Samsung, a Huawei, um, you had no option but to go to a semiconductor supplier and ask them to give you silicon. You could participate in the specification process. But bear in mind, if you are an Intel, right, and Dell goes to them, Dell says, listen, I need functions 1 to 10. And Intel is not selling only to Dell, they have a lot of other customers. And they will
Right.
say, out of 1 to 10, I will give you 1, 2, 3, 4, 5, and I'll give you 9 and 10, but the others you'll have to wait until my next chip, which is 2 years from now.
Okay.
Once you get into consumer, it gets a little more complicated, because when you have brands like Apple, and Apple, I keep taking the name of Apple because look at the kind of innovations they bring around.
Yeah.
Then, if you are a consumer brand in a hyper competitive market, you need those functions to differentiate yourself from your competitor, who is anyway eating at your market share, snapping at your market share ferociously. Second, you are writing a lot of software which is relying on these functionality to be available on the hardware, on the semiconductor chip. And therefore, at some point, these companies have said, what does it take to design a chip? We don't want to sell it to everyone else. We are not an Intel or a Qualcomm where we have 2,500 customers. I need it only for myself. At the most, I'll take it across my product line from a phone to a tablet to a laptop. And then you say, what does it take to build a VLSI design
Okay.
team? And then you go, and in any case, even your semiconductor supplier is getting his IP from companies like ARM in the UK, ARM. They're getting their memory from the Rambus in the US. They're getting a connectivity from somebody else. So you go and talk to those same guys. Then you go to the foundry, the fab vendors like the Taiwan Semiconductor Manufacturing Corporation, or TSMC, and you negotiate pricing there. Now, that means the classical semiconductor model, where you go to a semiconductor company to get your silicon, and then you have designers who work on product design, that model has disaggregated.
Okay.
And that has enormous opportunities for India, because we are today one of the hotspots for chip design, embedded software. And this disaggregated model holds enormous potential for India. For all the students who are watching this program, I can't think of a better point in time in history to enter this industry.
Okay. But where do they need to start? What are the things that they have to concentrate on when they exit from engineering if it's not part of the syllabus?
So on the syllabus issue, good thing I think industry is now realized that we can't leave it to the colleges to do skill development. I mean, training. We need to be actively involved. We need to get our technologists to be taking lectures and uh, doing labs and things like that. That's point number one. Point number two, as far as students are concerned, there is a famous colloquial phrase in Hindi. I'll translate for those who don't know it. But अगर फंडे गोल है तो कुछ भी नहीं चलेगा. If your fundamentals are weak,
Yeah,
it doesn't matter what. And I think it comes from the construction industry where the foundation is weak, your entire superstructure will collapse, right?
right.
So learn the basics. And this comes back to, when I was in Philips, for example, we would actually take our graduate engineer trainees and put them through basics of physics and algebra and problem solving skills and so on and so forth.
Okay.
Today we have fancy names like design thinking and critical thinking and systems thinking, but
Yeah.
ultimately it teaches you that you need to be able to figure out what is important, what are the fundamentals, and you have to know. I mean, as this gets more complex, the chips get more complex, the fabrication processes get more and more complex. uh, Math, physics, and if you want to get into manufacturing, then chemistry. These become absolutely critical.
Okay. There's been the media has focused on the so-called nanometer, nanotechnologies, which is uh, from 10 to 5 to 4, and saying how small the chip is. What is your take on that obsession versus the disaggregation which you just spoke of?
No, look, there's this famous saying that is Moore's law coming to an end? And I was at a conference recently where somebody said there has been more written about the end of Moore's law than what Moore himself predicted and wrote. So entire conferences run on when is Moore's law going to end, right?
Right.
Um, and let me be honest, Venu. I think the amount of gray hair on my head testifies to the fact that I've played that game. You chase miniaturization, you chase technology for its own sake. But today, I think the pushback is starting because the smaller the geometry, the higher the complications in engineering, things like electrical crosstalk and so on and so forth.
Okay.
And at some point, and remember, these chips go into products which are used in the real world. So if you are, for example, using a very, let's say you're using a 7 nanometer chip and you want to put it on a battlefield in Rajasthan. Um, One, the extreme temperature conditions will create problems. And at some point, when this is going at full scale, all your other issues with crosstalk and all that begin to affect system performance. So there is pushback now happening to older nodes. So the the golden rule here is look at what is the end application that you're going to use, design the chip for that. And
Okay.
a couple of years ago, I moderated a panel on how do we do products in India. I won't take the name of the
Okay.
company. One of the companies was talking about um, you know um, telecom product that they were piloting in Chennai, and they had this beautiful, fantastic technology. They had this beautiful clean. Somebody forgot to tell them, and they didn't realize themselves that Chennai is on the seacoast. So within a year, Madras Telephones goes back to them and says, the box in which you've given this is completely rusted.
Wow.
So,
Wow.
you know, when and this proves the importance for what I call systems thinking. Understand the application in which your product is going to be used, and then design accordingly, right from the outer casing inwards to this integrated circuit. And similarly, I
Yeah,
mean,
this
we
is
see this
yeah,
all the
this is
time.
such an important
You
lesson.
see
Yeah.
this, you see all the time. You try to check in on some of the airline websites. Let's not take names. The check-in option is buried three levels deep. So the person who designed the GUI has never flown an aircraft.
Yeah, absolutely. 100%. Your own career, at what point did you decide that you wanted to turn entrepreneur? You felt that you could make more of a contribution as an entrepreneur. What were you going through?
Okay. If you know more about what is happening in Frankfurt and New York and London and Hong Kong and wherever else, you don't know what is happening in Delhi and Chennai and Bangalore and Mumbai and Hyderabad. And that was my case. I was having a very successful career running these global product lines, traveling the world, all of that. And then the India Semiconductor Association was set up in 2004, and I was participating in it. I was working for Philips at the time. Philips was a member, and there were some market research studies that happened. I was part of the task force which participated, and all of a sudden I realized that the most happening place from a growth point of view was India, and I wasn't participating in that whole story.
Okay. Okay.
So, and then I had also hit that point in my career where you're saying, been there, done that, what next? Right. And
Right.
uh, again, I didn't want to go to headquarters. I didn't want to go live in the Netherlands. That was always an option. Didn't want to do that. I was also beginning to look at the macro numbers. The whole fascination with macroeconomics never quite went away. And
Okay.
I was looking at these market research numbers, and I said, India is the biggest, most happening market. Look at our compounded annual growth rates. We are in double digits. None of the markets I'm selling into have those kind of numbers. Plus, there is that whole thing about, can I contribute something back home? Can I help to
Right.
uh, build something for India? And that was the trigger. And when I started off in 2007 on my entrepreneurial journey, I guess God was very kind to me. So the first several years were a dream run, and then
Okay.
2010 happened.
Okay. And what happened in 2010? Okay, the global this thing was there, but how did it
So the
impact
global
India?
the global recession happened, and
Yeah.
consultants suddenly became the most worthless commodity. Nobody wanted to deal with consultants. They were struggling to deal with their own people,
Okay.
and everything that I had learned in my corporate career, all the business strategies were proving to be zeros.
Okay.
And that's why I often tell people I have two MBAs. One which I got many, many years ago from one of the academic institutions, and the second is an MBA from the University of Hard Knocks. And trust me, Venu, I'm still paying the EMI on that.
And you can't decide when you're going to be enrolled or when you're going to graduate.
Exactly. I'm now enrolled for the doctoral program.
Yeah. I think anyone who's listening to this should understand that, the career path is never going to be one seamless right to the top, no matter how it starts, whether you start with an extremely high salary, because there's this obsession with saying, what is it that you're going to earn first? Without any idea of what delivering on that job means, which is where I think a whole lot of other issues come up. But
Yeah.
I'll park that for the moment. The post 2010, what are the changes you're seeing now? Because yes, there is a rebound. You're beginning to see some level of interest, and India is definitely going to be a big player because our market is huge. So, what is it that you see changing out here?
Couple of different things. One is, of course, as you said, the market is huge. I think also in the last 7 to 10 years, and I'm speaking for the electronics industry, right? We've built global scale capacities now. Um, if I were to try and capture this as a soundbite, I think we've learned to believe in ourselves. Earlier, we always needed that, you know, if I put it slightly derisively, we needed a white man to approve what we were doing. We needed that approval from overseas. You had a contract from the US, so therefore you knew what you were doing, right?
Right.
You could make a product and sell it in America, therefore you were successful. Today, I think that has changed. Today, the fact that, and there are lots of people who are saying, I will, make for India. Um,
Yeah.
but in the little piece of the woods that I am in, which is the electronics industry, I always say that I think of what I call as products that are conceived in India, designed in India, made in India, but sold and used worldwide.
Yeah.
And that adds a different dimension because then you're talking quality, you're talking packaging, you're talking, I mean, people need to realize that if you export and you're into in the B2C business, cost of returns comes on you. People don't
Yeah.
realize that. So you will have to make sure that you build a product which is good enough not to get returned, not for performance issues anyway. Second, and I've written an article on this about the how we need to obsess with quality, and um, I quote, quote something. The first time I did a project, I won't name the company, one of the large engineering firms in India, and I had a board. I was carrying it to Hong Kong to demo to a customer. This was when I was in analog devices, and I got a badly dot matrix printed manual where they had not even bothered to change the ribbon, and I could barely read.
My
And
God.
I am at the airport. I call the project manager and I said, I can't read the manual. And he says, oh, take it to a Xerox shop and ask him to darken it.
Oh
Without
God.
realizing, here is a client at an airport waiting to catch an international flight, right? And many years later, I was with a large conglomerate. I was a one-man show operating out of Delhi. And I remember if I had to submit a letter to the government, I would painstakingly, I had no secretarial help, nothing, but I would painstakingly print the address and even the logo, take it on a, I didn't have, this was a one-man show kind of office,
Right.
but I would take a white envelope, print, stick all this, and then give it. And I remember somebody asking me, why are you doing this? And I said, it doesn't matter. I can handwrite it, but there is an issue of what is the quality because you represent a multi-million dollar corporation. And the guy receiving it needs to know that it is coming from a company of that scale. So I think
Yes.
you have to have that obsession with quality. You have to understand that graphical user interface, the whole UX, as we call it today, the user experience, has to be
Yeah.
taken care of. Otherwise, it won't work. Sorry, Venu, you asked me a very, very pointed question. I gave you a long, rambling answer.
It wasn't rambling in any sense of the word because these are the nuances that take a lifetime to learn. You can probably, find out about your job and function in the first 6 months. I keep telling people this,
Yeah.
but the nuances take a lifetime. And that is what builds the difference. It's not the
Yeah.
knowing the job. Yeah, I know what the job is, but how do you deliver and take it to a different level? I mean, what you just told me about disaggregation and how is it's going to change the market is not something that I could have got out of media, is not something that I could have got out of speaking to people who are obsessed with just one part of that chain. It's because you have both. You have that obsession with the small details and the overview, that this works. It's not, which I think people will have to learn when they do it for themselves. That it is never a question of, yes, you can take the middle path as far as a career goes, but execution, you have to figure out which way you want to. There are parts when you have to get down to the details and worry about that. There are times when you have to step back and then take the overview.
Yeah.
So you had mentioned that the creation of the fab is as complex. So it's not just repeating something. So if you could expand on that, because I know that's another thing that you're deeply involved with and you understand the problems from an execution perspective.
So, a semiconductor fabrication facility, or fab as we call it, at the, I have a favorite analogy, if you permit me to give it to you. Um, and I always say that a country deciding to build a fab, whether it's in the private sector or public sector, doesn't matter, right? Country deciding to build a fab is like a country deciding to buy an aircraft carrier.
Okay.
At one level, an aircraft carrier is a large mechanical ship. I mean, if you look at the INS Vikrant, the new one, the second one, it's what, 45, 48,000 tons. It is a ship. And, it has its own uh, guns, it has its own missiles, it has radars, it has onboard aircraft and helicopters, and it has 1,500 people or so on board, men and women who run the ship. But when, and why would you buy an aircraft carrier as India? Why would you buy it? I mean, yes, you do have, you're a peninsula, so you have two long coastlines. But you don't buy an aircraft carrier just to defend your shores. I mean, you could theoretically have, if I can be permitted to use that word, a Coast Guard plus plus, right? You could have several ships, destroyers, which patrol the rivers. But it comes down to, do you want what is, and I'm borrowing from Clayton Christensen's words of blue sky thinking. Do you want a blue water navy or a white water navy? White water, where do you
Wow.
get white water? Close to the shore, right? Where do you get blue water? Outside in the deep sea. So the moment you say that I want to project my power and I am going to impose an exclusive economic zone, and my sphere of influence goes from the Red Sea on the west to the South China Sea on the east. Of course, a lot of countries in between will have objections to what you're saying. But then you say, hey, I'm India, I'm a subcontinent, I have the might to do this, and I'll flex my muscle to prove that I have the might. And that's when you go and buy an aircraft carrier. And when this large ship puts to sea, she doesn't sail alone. She sails as what is called a carrier battle group. So there are destroyers on the air, on the water, there are aircraft in the sky, there are submarines underneath, and there is a bubble created of about 150 square kilometers. If
Wow.
you are not authorized to be in that bubble, in the air, on the water, under the water, you will cease to exist, because this is a collection of ships and submarines and aircraft. If I may be permitted some hyperbole, they are looking for trouble. When they find it, they will engage. Right.
Okay.
Now let's come to a fab. At the core, a fab is a large, continuous process, highly polluting chemical factory. It's, the technology is esoteric. It is a beautiful technology. If you like technology, I can talk to you ad nauseum about nanometers and so on and so forth. But what is the input? There are large amounts of water, there are very poisonous gases, chemicals, the effluent that it creates is extremely toxic, needs to be treated multiple times, and so on and so forth. The product it makes is something without which society will cease to exist as we know it. Today, society as we know it, right from, a child is born, you give a rattle to the baby, and you have that electronic chip and a little speaker which goes, ba, ba, black sheep, have you any wool? Right? To the very sophisticated life-saving equipment in the, intensive care unit of a hospital, to the avionics on an aircraft, everything depends on electronics and that little computer chip. Second, COVID only accelerated the process. Society itself is getting digitalized, and digitalization means electronics is key to making it happen. So you need to have those fabs. Now, the fab in which you make it is enormously complicated. You take a fab of, let's say, there are clean rooms. A clean room is a place where temperature, humidity, dust, everything is controlled. If you look at the city of Delhi, Venu, 1 cubic meter of air will have 35 million particles of dust. 35 million.
Wow.
If you look at a clean room where we fabricate the chips, it is less than 10 per cubic meter of air, right? If you look at an operation theater where you and I, God forbid, have a surgery, that will have probably about 5,000 particles of air, of dust. So, one, you have to create that environment. This is not the show. I can talk about laminar airflows. If people are interested, I've written a series of articles on this, which is pinned to my LinkedIn profile. Second, you need to have very specialized piping for bringing in all these gases into the machines which will fabricate it. There is a very strict rule about how you do it. There are about anything around between 50 and 60 gases come in. Most of the pipes are double sided, so there is the pipe in which the gas goes, there is a vacuum column, there is another pipe shielding it, there are sensors in between to detect leaks. Some of these gases will explode on contact with oxygen.
Wow.
So you have to make sure there are no leaks. The water that comes in, we require enormous amounts of water. And the water that comes in goes through about 5 or 6 stages of purification before it can come into process. So
Okay.
probably the most pure form of water that any of us know is the water that we pour into the distilled water we pour into the car battery. This is far more pure than that. And
No,
the effluent that comes out is basically, there's a little river flow coming out of the fab, and that has to be treated about 14 or 15 stages before it can be evaporated out.
wow.
So
And
enormous
I'm glad
complication.
you started out with the aircraft
There are
carrier
rules
analogy.
in which
Sorry.
you were saying,
No, you were talking of
you
the
started
kind
saying
of
about the
rules
aircraft
and
carrier analogy.
technology that needs to be harnessed in order to make the fab work. So the effluent itself needs to go to about 14 stages before it's evaporated.
I have an unstable internet connection.
Yeah, but we'll manage. I think at
Okay.
least the
I
audio
think you'll
part
have to
of it,
do
there
some
are certain
edits.
points at which, but we can manage.
I missed that
But
entire. You started saying about aircraft carrier, and then I lost you completely. I'm sorry. You'll have to
okay,
edit this out.
what I was saying is that you explained or set a context beautifully with the analogy of the aircraft carrier and why it's necessary. Because you can come with the economic argument for fabs and you can come with the reason why it actually needs to exist. Because if it's now down to a company level, which is at the global level, saying, I need to make my own chips. There is no way a country can get away from that and then say, I will find suppliers who do it, because there is a need to do some of these things yourself and figure out the places. So, what are the fabs in India going to be making?
So, okay, there's one thing that people need to understand. Fabs, just like any factory, is a game of volumes.
Okay,
So there are, we talk in terms of the fab capacity is measured in terms of a silicon wafer. A silicon wafer
okay,
is a 300 millimeter, that is a 12-inch, uh, very pure piece of silicon, which is then onto which the chip architecture, the design is etched onto it using
right,
photosynthesis and so photolithography and so on and so forth. On a particular wafer, there can be multiple chips which are etched onto it. Depending on the size of the chip, there could be anything from 10 to 100. And then they are cut out The cutting process, very broadly, is similar to how you would cut a diamond from a,
Okay.
extract a diamond from a stone. It's called ATMP, assembly, test, mark, and package. Let's not get into that process. But one thing you must remember is that there is no such thing as an India capacity, because these chips, we use multiple types of chips across multiple geometries. So some could be 7 nanometer, some could be 180 nanometer, some could be 65. It's a combination of everything. A fab is designed to do a particular set of chips,
Okay.
and then it doesn't matter there, whether you're making a chip for a medical electronics application or for an automotive. As far as the fab is concerned, again, um, I'm sorry, I'm giving you a lot of analogies, but if you are a baker, your IP is your recipe. You don't care who the, you have to buy the oven because the cake has to be baked. But if tomorrow your
Right.
neighbor comes along and says, hey Venu, I'll getting into the bakery business, I don't know how to make recipes, but I'll buy a lot of ovens and I'll buy a lot of ovens, that makes life
Right.
easy for you, because you don't have to worry about now ovens, cleaning, electricity, and you focus on your IP, which is your recipes. So if you're a company like Qualcomm, what we call fabless companies, so they focus on the intellectual property, solving a real world problem, how to make cell phones faster, cheaper, better. And then they go to a fab like a TSMC and get it done there. So when the disaggregation happens, Apple, for example, makes its own chip, Samsung makes it, Xiaomi makes it, Cisco makes it, and they all go off to a foundry and say, we know what our products need in terms of functionality, we will design the chip, you make it and give it to me.
Okay.
So,
Okay.
so when India makes these fabs, number one, the entire, there is no question of addressing all of India demand. Point number one. So you will be catering to a part of it. Point number two, given the humongous capacity you have, 50,000 wafers being done every month, right? Which means about 2,000 wafers are running a day, and then do the math into how much per hour and so on and so forth.
Uh-huh.
You need to make sure that you have customers who will use it. And I
Yeah.
often say, running a fab, the business economic model for running a fab is exactly the same as running an airline. Because if you buy a A320 and you have 170 seats on it, you need to make 170 people sit on those seats. Otherwise, you're going to lose money. So,
Yeah. Yeah.
and the fab, the guy who runs the fab, whether it is the Tatas or anyone else or TSMC or Global Foundries, they have to go and find X number of Apples and Ciscos and Qualcomms and everybody else, because they are in the business of selling capacity. End of the day, it's a very high tech factory with a large amount of capacity which has to be utilized.
Wow. That's
And the
that's
airlines
amazingly
will.
well explained. I hope people who watch the program understand it, because you have broken it down not in terms of the technology, which is awesome, but by using analogies that make it simple to for people to grasp what this is about. I only hope that the students who watch this have the patience and the understanding to know that everything in life can't be easy. You can't explain everything in life. Explain like I'm five is a favorite on Reddit. But if you are to explain everything that like a 5-year-old, then when is it that you're going to grow up? You know, there's a point at which you need to grow up and then say, okay, there are decisions you take as an adult. There are things which are beyond what 5-year-olds can understand. And they might understand 5% of what it's enough to function as a 5-year-old. But you can't function as a 5-year-old at the age of 30 or 40 or 50. And that lesson somehow has been lost in communication today. We are talking of everything being easy. So,
We as a society dumb down too much.
yes, but that's another favorite rant. And like I told you, I'm sorry, but we'll have to close at this point because we've been speaking for an hour, almost an hour.
Oh, okay, I didn't realize.
So, Thank you for coming on the show. It's been wonderful understanding what you do, how you do it, how you approach it, and you've managed to combine everything: a personal journey, a professional journey, an understanding of what the market operates as. And this, I'm sure, is only the taste maker, because I was very clear when we started out that we wouldn't be able to cover much ground. But I wanted this to be the point at which people came into this, saw it, and then understood the potential. Because you don't have to run after one profession alone. There's a lot you can do. So, is there a quote in closing that you would like to address the audience and leave them with?
Oh, I'll always say that, you know, don't sit on the past, number one, especially to, people who have had early success. And people become complacent, and across not just corporate life, but across society, we see too many people who ride on past successes.
Yeah,
And I don't know who said this. I read this on the internet somewhere, that for a filmmaker, he's only as good as his last Friday opening. And I often say that you may have been a great performer in the past, but that doesn't mean that you will perform well today.
yeah,
So, my favorite, I urge all your listeners to go and find out that speech and listen to it. And I often say that the one of the finest speeches I've ever heard is Steve Jobs' Stanford commencement address, where he
yeah.
concluded by saying, "Stay hungry, stay foolish." And Venu, to pick up from one of your writings, I will add, "Stay curious" to it. Because you wrote that beautiful piece on LinkedIn and about being curious. And I would just add that bit to Steve Jobs' "Stay hungry, stay foolish," which is "Stay curious" as well. And otherwise, life is going to be very boring. And if you are hungry,
Yep.
foolish, and curious, life gets to be very interesting.
Wonderful. On that note, PVG, thank you very much for the honor of coming on the show. It's been a pleasure. It's been an education. And there are things that I have understood because of how you explained it. Thank you for taking the time.
Thank you.
That was PVG Menon, who manages billion-dollar projects in the semiconductor industry. And he talked of what a great future there is for people who are willing to take that leap and understand what is involved. It'll involve work on your part, it'll involve work on understanding what this business is about. But doing that is where the change is going to come. Next week, we'll have another wonderful guest, another career journey. And thank you, as always, for listening.